Now, in order to understand the concepts in a more detailed way, let us take an example problem, right? Something like this. It says for x1 plus 2x2 plus 3x3 plus 5x4 is equal to b1, 2x1 plus 4x2 plus 8x3 plus 12x4 is equal to b2, 3x1 plus 6x2 plus 7x3 plus 13x4 is equal to b3. It is to be reduced to Echleon form, and the column space and null space is to be found out, and the particular solution for Ax is equal to 0, 6 minus 6, and the complete solution is to be found out, right? So here if you observe, Ax is equal to 0, 6 minus 6 is b1, b2, b3 value, which we will use in order to obtain particular solution and the complete. First of all, let us express the given system in Ax is equal to b form. That is, if I have to consider the coefficients of x1, x2, x3, x4, the matrix A would be something like 1. The matrix, if I have to consider the variables x1, x2, x3, x4 and the coefficients, corresponding coefficients, matrix A would be 1, 2, 3, 5 and 2, 4, 8, 12, 3, 6, 7, 13, and x, we can write it as x1, x2, x3, x4, and on the right hand side it is b1, b2, b3. Now it is slightly confusing. Here there are 4 variables, but on the right hand side there are only 3 values, b1, b2, b3. So it is slightly confusing. Here we need to check with number of rows in A, right? 3 cross 4 and 4 cross 1 makes it a 3 cross 1 matrix. So dimensional analysis, which I mentioned in my previous video, one of my previous videos. So it is very important and gives us a sense of correctness, right? So this is in the form of Ax is equal to B. Moving ahead, so if I go with the row operations, so if I have to start with the given matrix, A is equal to, or the obtained matrix from the equations, if I have to write from the previous slide, that is 1, 2, 3, 5, 2, 4, 8, 12, 1, 2, 3, 5, 2, 4, 8, 12, 3, 6, 7, 13, right? And if I have to append B to it, it would be B1, B2, B3. Now going with the row operations, R2 dash is equal to R2 minus 2R1 and R3 dash is equal to R3 minus 3R1. We get A as, so R2 minus 2R1, R2 dash is equal to R2 minus 2 times R1, that is R1 remains as it is 1, 2, 3, 5 and B1, right? And R2 goes 0, R2 minus 2 R1 0, 8 minus 6 2, 12 minus 10 2, and this would be B2 minus 2 B1. That is, we are applying the same row operations on elements of column vector B as well. Just to keep it in your mind, so you need to apply the same row operations. Right now, it is R3 minus 3R1, 3 minus 3, 0, and 6 minus 6, 0, and 7 minus 9 minus 2, and 13 minus 15 minus 2. So here again R3 minus 3R1, that is B3 minus 3B1, right? And when we do the row operations, R3 dash is equal to R3 plus R2. From this matrix, we will see that the matrix becomes 1, 2, 3, 5, 0, 0, 2, 2, this being B1, and this unchanged with B2 minus B1, sorry, B2 minus 2B1, and this becoming 0, 0 with, and this becomes B3 plus B2 minus 5B, B3 minus 3B1 minus sorry, plus B2 minus 2B1, so that minus, yeah, the minus 3 minus 2B1 and minus 3B1 they together make it minus 5B1. So we see that this matrix is in the form of UC, that is Echleon form, and the matrix column matrix C with changes in B1, B2, and B3. That is when the row operations are done on B1, B2, B3 as well. Now the condition for this to have solution would be B3 plus B2 minus 5B1 should be equal to 0 in order to equate these two. So this value should be equal to 0. That is the condition for this particular matrix. Now for column space, the combination or the linear combination of column vectors with pivot elements would be the column space. That is, we see that the column vectors with pivot elements are column 1 and 3. Hence, the column space would be, so 1, 2, 3, that is the first column, and 3, 8, 7. So this would be the column space. The special solution for this matrix can be found out by using Ux equal to 0, right? So now if I have to write U, that is 1, 2, 3, 5, 0, 0, 2, 2, and 0, 0, 0, 0. That is U is equal to 1, 2, 3, 5, 0, 0, 2, 2, 0, 0, 0, 0, and X was X1, X2, X3, X4 is equal to 0, implies X1 plus 2X2 plus 3X3 plus 5X4 is equal to 0, and 2X3 plus 2X4 is equal to 0, implies X3 is equal to minus considering x2 and x4 to be free variables, if I have to represent x1 in terms of x2, x3 and x4, it would be minus 3x3 minus 5x4. Now, since x3 is equal to minus x4, I can write it as minus 2x2 plus 3x4 minus 5x4, that is minus 2x2 and minus 2x4. So we have x1 and x3 represented in terms of x2 and x4. Now, for x2 is equal to 1 and x4 is equal to 0, we get x1 is equal to minus 2 and x3 is equal to 0. Therefore, x1, x2, x3, x4 will be minus 2, 1, 0, 0. This is one of the solutions. Now, for x2 equal to 0 and x4 equal to 1, we get x2 is equal to 0 and x4 is equal to 1. We get x1 is equal to minus 2 again, and x3 is equal to minus 1. Therefore, x1, x2, x3, x4 is minus 2, 0, 1 and minus 1 and 1. That is, xn is minus 2, 1, 0, 0 into x2 plus minus 2, 0, minus 1, 1 into x4. Right? So this would make it general solution or special solution. Special solution of given A for the system. 1, 2, 3, 5, 0, 0, 2, 2, 0, 0, 0, 0. x1, x2, x3, x4. What was our b1, b2 minus 2 b1, b1, b2 minus 2 b1, and b3 minus b2 minus 5 b1. Let me check if this is the right. b3 plus b2 minus 5 b1 plus b2 minus 5 b1. Now, given b1 is equal to 0, b2 is equal to 6, b3 is equal to minus 6, which implies 1, 2, 3, 5, 0, 0, 2, 0, 0, 0, 0, x1, x2, x3, x4 is equal to By substituting values of b1, b2 and b3 in this equation, we get b1 as 0, b2 minus 2b1 as minus b2 is 6, so b2 minus 0 is 6 minus 0 6, and b3 minus 6, b2 plus 6, so b3 b2 cancels, and 5 times b1, that is 0 is 0, so 0 6 0 is something we get. We have 1 2 3 5 0 0 2 2 0 0 0 0 into x1 x2 x3 x4 is equal to 0 6 0, implies x1 plus 2x2, that is multiplying this row and this column, plus 3x3 plus 5x4 is equal to 0, and 2x3 plus 2x4 is equal to 6, that is x3 plus x4 is equal to 3, and x3 is equal to 3 minus x4, and if I have to write for x1 again, x1 is minus 2x2 minus 3x3 minus 5x4. Back substituting value of x3 from here, I get minus 2x2 minus 3 times 3 minus x4 minus 5x4. It is again representing x1 and x3 in terms of x2 and x4. Minus 2x2 minus 2x4 minus 9. So x1 is minus 2x2 minus 2x4 minus 9, and x3 is 3 minus x4, and x2 is itself, and x4 is 8. Therefore, when x2 is equal to 0 and x4 is equal to 0, we get a particular solution, x1 as minus 9, x2 as 0, x3 as 3 minus 0, that is 3, and score as 0. So this is a particular solution. Therefore, from special solution and particular solution, we can write minus 9 0 3 0 plus xn was minus 2 1 0 0 x2 plus minus 2 0 minus 1 1 x4, that is minus 2 1 0 0 x2 plus minus 2 0 1 1 x4. Let me double check one more time. Yeah, minus 2 0 minus 1 1 minus 2 0 minus 1 1 minus 2 1 0 0. So this would make complete solution. This would make complete solution of given system. which is nothing but linear algebraic equations. System of linear algebraic equations, which we started off with, that is this particular system of equation. Hope the viewers are clear with respect to solving of linear system of equations, which is given as shown on the slide. So a little bit of practice and solving more and more problems, keeping in line, though it is a bit lengthy problem, so it is good to solve a few more, taking different permutations and combination and trying to get the desired solution set. So it would make it easier and faster. More and more you practice, more faster will be your solution finding. So happy learning, and let me know if you have any other questions or comments on the problem being solved.